That seemed pretty simple.
Yes, it did.
It's amazing how easy EnSuite is to use to perform tasks that would otherwise be extremely difficult for a non-engineer using a CAD system. One challenge that manufacturing companies face every day is minimizing the impact of engineering changes. How can EnSuite help with this?
Well, EnSuite can compare parts of two different CAD files. It can compare geometry to geometry, geometry to points identifying deviations with colors, and compare assemblies showing differences with colors. I emphasize this is all done without the need for a CAD license. So it facilitates the ability to spread new information across the enterprise. Estimators can identify differences in new revision levels to see if a part needs to be requoted. Manufacturing engineers can compare files to see what impact the new design may have on their assembly line. Purchasing can examine a new assembly to see if new material suppliers may need to be identified. This feature is especially useful for quality control purposes and can be used as the first level inspection.
Do the parts that are being compared need to be from the same native CAD format?
No, EnSuite is a multi-CAD product. It is not a plug-in to any single CAD system, so files of many different types can be compared.
Okay, so let's watch a quick sample of EnSuite comparing parts.
Parts to be compared can be arranged as tiled views in EnSuite, and specific engineering information across both files retrieved and compared. Here we see the part on the left with 3 bosses, and the one on the right with 4. This sort of tiled, simultaneous views can be very useful for first-level visual inspection and quality control. Using a click of a button, these parts can be compared, geometry with geometry or geometry with points. The former compares parts by overlapping geometry, and differences can be seen by adjusting color and transparency of the parts. The example we are showing in this demo compares geometry with points. For example, compares geometry of the first part by overlapping points on the second part. Color codes can be used to highlight differences. EnSuite also compares assemblies. Differences in the assemblies are highlighted in a tabular representation with different color coding for missing components, new components added, mismatch in quantity of components, or even a difference in transformation or placement.
Let's take a look to see how EnSuite can help with your purchasing and quality departments.
Okay, it's easy to access bill of material parent and child information. You can access an indented BOM, print it, and save the BOM to an Excel file. This will help your purchasing department identify all of the components necessary directly from the native CAD file. Materials can also be assigned to each component to determine part mass for estimating purposes.
Great! And I can see that the purchasing person would not need any special CAD training. It's great that the purchasing department would not have any dependence on the engineering department in order to do their job.
Yes, any department that needs access to critical CAD information can get it using EnSuite and without requiring the CAD license or experience. Along with accessing BOM information, this next demo shows how your quality department can take a look at assembly relations like measuring contact area, checking interference, and checking clearance. EnSuite can access the bill of materials of an assembly at a click of a button. The BOM displays total number of parts, number of unique parts, and the quantity of each, among others. An indented BOM can also be generated that mirrors the assembly tree hierarchy. Users can print the BOM using the Printable View option or even save it as an HTML file. For easy editing or performing computations, the BOM can be saved to a comma-delimited CSV file format that is compatible with Microsoft Excel. EnSuite also provides parent-child information in an assembly. Parts queried can be selected from the interactive view area as shown in this example, or even from the assembly tree. Parent-child info for subassemblies can also be retrieved in a similar manner. EnSuite can be used for checking interference between parts in an assembly. When a part is selected, EnSuite displays the list of parts interfering and also the interference volume. Users can also get a list of parts by touching a specific part and the respective contact areas. EnSuite users also have the ability to list parts at a certain clearance. Clearance can be adjusted and the results, viewer and part names, are dynamically updated.